Hi and Assalamualaikum. My name is Muhammad SAHID, and in this video, my team and I will present about our project on object recognition by using CNN, focusing on flower recognitions. These are my fellow team members, and our team consists of 4 members. A convolutional neural network, or CNN, is a type of deep learning model designed to process and analyze the visual data, such as image and videos. CNN are inspired by how the human visual system works, making it a good approach to effectively solving the tasks that involve classifications and recognitions. And in this mini project, the classification will be done on flowers. Since flowers is a God's creation that contribute a lot benefits to the living things and the environment, a good understanding and the correct classification of flowers is very important, especially to identify the new or rare species when found, so that it can lead to the discovery of innovative use in the field such as medicines or even skincare.
Hi, my name is MAISARAH YASMIN. Today, I will explain about the objective and dataset preparation. First, the objective: to utilize convolutional neural network (CNN) for the classification of flowers. Next is a network will be trained on the diverse set of images include daisy, lilac, tulip, and lily using MATLAB software. To optimize the accuracy of flower identification, various network, setting, and structures. To determine how this parameter values network designs impact the validation accuracy of CNN. Next is dataset preparation. We have 3, which is input data, output classes, and segregation of dataset preparation. First, for the input data, each flower category needs 101 images. 100 will use for the training and validation phases, while 1 is for testing phase. Total of flowers across the 4 categories are 404. These are the example of our flowers by categories. Okay, next is all flowers file were kept in a main folder named flowers. Then we set the pictures to 100 times 100 pixels and converted to JPG format, use MATLAB's function and change the background to black. This is the coding that we use for our project. Okay, next is for the output classes is each folder containing 100 flowers images each. To organize the input data, and the model is trained to classify the images into one of these 4 classes based on features learned during training. For each input images, the model will output one of these 4 classes based on the flower type prediction. Okay, next is segregation of data. Each flower has 101 images, which means 100 images will be used for training and validation. 1 is for the testing. Dataset is divided into 3 subsets, which is training dataset, validation dataset, and testing dataset. For the training dataset, total of 300 images, approximately 75% of the dataset, are used for the training phase. It will learn the characteristics and patterns of each flower category. Next is validation dataset. Total of 100 images, approximately 25% of the dataset, are used for validation. Validation dataset is used to evaluate the model performance during the training process. It is to make initial predictions, help to avoid overfitting where the model memorizes the training data too much, resulting in low accuracy. Last is the testing dataset. Total of 4 images, 1 image per category, are reserved for the testing. These images are completely excluded from the training and validation processes. It will use to provide an unbiased evaluation of the model's performance on unseen data. Thank you.
Moving on to the experiment phase. So, what is the objective of the experiments? The objective of the experiments is to evaluate and compare different neural network architectures and to determine the most effective model based on image classification tasks. So, we have done for about 12 experiments, and let's move on to the experiment explanation. Moving on to experiment phase. So, we have conducted 12 experiments with different parameters and experiment results. For experiment 1, we use 4 convolutional layers with 50, 85 and 100 filters with 2 times 2 max pooling layers and 10 epoch with a learning rate of 0.04, and the validation accuracy is checked for every 30 iterations, and it achieved a validation accuracy of 72%. For experiment 2, we use 4 convolutional layers with 8, 32 and 8, 32 filters incorporating batch normalization with 2 times 2 max pooling layers and 1 times 1 max pooling layers with 4 epoch with a learning rate of 0.0006, and for validation accuracy is checked for every 25 iterations, and it also achieved a validation accuracy of 72%. For experiment 3, we used 3 convolutional layers with 25, 85 and 150 filters with 2 times 2 max pooling layers and 15 epoch with a learning rate of 0.05, with validation accuracy is checked for every 30 iterations, and it achieved a validation accuracy of 73%. And for experiment 4, we use 1 convolutional layers incorporating batch normalization with 2 times 2 max pooling layers and 18 epoch with an accuracy with a learning rate of 0.0006, and a validation accuracy is checked for every 15 iterations, and it improved the validation accuracy to 76%. For experiment 5, we use 4 convolutional layers with 8, 16, 32 and 32 filters incorporating batch normalization with 2 times 2 max pooling layers and 9 epoch with a learning rate of 0.001, and the validation accuracy is checked for every 30 iterations, and further improved validation accuracy to 81%. For experiment 6, we use 2 convolutional layers with 25 and 85 filters incorporating batch normalization with 3 times 3 max pooling layers and 24 epoch with a learning rate of 0.0005, and the validation accuracy is checked for 38 iterations, and it achieved the highest validation accuracy of 83%. For experiment 7, we use 4 convolutional layers with 10, 38, 50 and 66 filters with 2 times 2 max pooling layers with 30 epochs with a learning rate of 0.004, with validation accuracy is checked for every 30 iterations, and we achieve validation accuracy of 83%. And for experiment 8, we use 5 convolution layers with 128, 16, 32, 128 and 32 filters, incorporating batch normalization with 2 times 2 max pooling layers for the first 2 layers and 1 times 1 max pooling for the remaining layers, and we use 9 epoch with a learning rate of 0.001, with validation accuracy is checked for every 30 iterations, and we achieve a validation accuracy of 81%. For experiment 9, we use 4 convolutional layers with 32, 64, 128 and 256 filters with 2 times 2 max pooling layers with 20 epoch with a learning rate of 0.001, and validation accuracy is checked for every 30 iterations, and we get a validation accuracy of 88%. For experiment 10, we use 4 convolutional layers with 32, 64, 128 and 256 filters with 2 times 2 max pooling layers with 30 epochs with a learning rate of 0.003, and a validation accuracy is checked for every 30 iterations, and we achieve a validation accuracy of 89%. For experiment 11, we use 4 convolutional layers with 16, 32, 64 and 128 filters with 3 times 2 max pooling layers with 20 epochs with a learning rate of 0.001, and validation accuracy is checked for every 30 iterations, and we achieve a validation accuracy of 90%. For the last experiments is experiment 12 with 4 convolution layers with 32, 64, 128 and 256 filters with 2 times 2 max pooling layers with 20 epochs with a learning rate of 0.0005, and we use validation accuracy check for every 30 iterations, and we achieve the highest validation accuracy of 91%.
Next is our best network architecture. For testing phase, we choose experiment 12 for our final network architecture as it has the highest accuracy among the other experiments, which is 91%. To get this highest accuracy, we decided to maintain the value of the maximum epoch, which is 20, and reduce the initial rate from 0.01 to 0.005, as it can produce more accurate result. Here we have a graph representing our 12 experiments, arranged from the lowest to the highest validation accuracy. This is our final network figure. For the input, here we have the image of different types of flower, which are tulip, lilac, daisy, and lily flower. And for the feature learning, we have 4 convolution plus ReLU with 3 pooling layers. And for the classification, we have flattened, fully connected, and softmax. Next, we also increase the filter size and the number of filters for the convolutional layer from previous experiment, which is from experiment 11. For example, from 16 3 times 3 to 32 3 times 3 convolution plus ReLU, from 32 3 times 3 to 64 3 times 3, and next from 64 3 times 3 to 128 3 times 3 convolution plus ReLU, and lastly from 128 3 times 3 to 256 3 times 3 convolution plus ReLU.
For the testing phase, a few pictures are going to be used as the test samples, one for each flower category. And the final train network with the best validation accuracy is going to be used for the testing. Now, let's proceed to the testing demonstrations. The first section before the testing process is to initialize the dataset, where this selected segment of code is where we need to put our part that containing pictures to be trained. And to make sure the correct part being read by the MATLAB, we can try to display the 20 random image by using this function. We can also read the size of each image for all labels. We can count the number of image for each label or flower type as well. And then from that, we need to split the dataset where we only use 75% of the total image for each label to be trained. And then MATLAB will randomly pick, and the rest will be used for the validation. And if we run this section, we can see the random 20 image with the rest of the output, where we can see the image size of all image, how many pictures for each of the labels that will be picked as the training set, which is 75 for each and 25 for validation set. Moving forward, this is the training network. It is consists of 1 image input layers, 4 convolution layers, 1 fully connected layers for 4 classes that indicate 4 types of flowers, and the training option of the training. And if we run this section, we will get the progress window. So this is the progress window that will show the result of the training. And then for the actual testing, this is the code section. We need to define the part of the image that we want to use for the classification here. For example, this is the part of the image that I'm going to use. So just simply copy the part. Let's say I want to test this picture first. So just paste the part in here. We use a single quotation only. We can use the double quotation as well. And if we run this section, it will display the image that we want to test. So we can confirm whether this is the correct image or not. So these two functions will resize the image to 100 times 100 pixels, and it will convert the image to RGB if necessary. And this is where the classification begins. It will classify and do the predictions to the image, and we will get the prediction score as well. And this will display the test image with the prediction, whether it is a daisy, lilac, lily, or tulips. And we can also sort the score based on the 4 prediction in descending order. We need to select at most 4 prediction because we only have 4 classes, which is 4 types of flowers. And we can display the top prediction graph. So let's try to run the test for these pictures, daisy 1. So we run this section. So this is the picture that will be tested. So run this section and we will get the result. So this is the top prediction graph for daisy. This is the prediction score, this is the correct level, and this is the score, which is 90.4%. Next is lilac 1. So we run these sections. This is the picture that we will test, and then we run the section and we will get the top prediction graph for lilac. This is the prediction score, this is the correct level, and this is the score, which is 99.1%. Next is lily 1, lily pictures. So run this section, this is the lily pictures, and then we run the classification section and we will get the top prediction graph, and this is the prediction score with the correct level, and the score is 95.9%. And the last pictures is tulip 1. So we run this section. This is the tulip pictures, and we also get the prediction graph for tulip. This is the prediction graph, and this is the prediction score with the correct level, and the score is 99.1%. So done for all pictures. This is daisy, this is lilac, this is lily, this is tulip. So all done with the correct level and high scores. So I guess that's all for the testing phase. Thank you.
The CNN model achieved an impressive validation accuracy of 91% in the final architecture, showcasing its strong performance in classifying flower categories. This result highlights the model's robustness and effectiveness in accurately differentiating between various types of flowers. The consistent classification accuracy across all categories underscore the reliability of the model for image classification tasks. Future research could focus on the fine-tuning network parameters and incorporating a larger, more diverse dataset further enhance the model's accuracy, adaptability, and generalizability for more complex classification challenges. That's all from us. Thank you for watching.